Hello dear students, good afternoon to all of you. Today we start about the basic concepts of transistor. So before starting the basic concepts about the transistor, first of all we see the outlines of today's class. As for today's class, the outlines are like this. First we consider the basic concepts, then we discuss classifications, then working principle. So this is the basic history of a transistor. Actually, transistor is invented in 1947 by three scientists. The three scientists' name is John Borden, Walter Brittain, and William Shockley. These three scientists are the main persons. Those are invented the transistor. Then, and basically it is in 1956 they got the Nobel Prize for this. And today, if we see each and every devices are based on the transistor. Actually, after discovery of the introduction of the transistor, then the electronics sector is continuously increasing towards a large evolvement of more number of devices and new technologies for different electronic devices. Then we know the basic concepts over the transistor. As for this, what is transistor? Actually, transistor means this is an electronic device, and this transistor is mainly known as the BJT, bipolar junction transistor. But simply we are telling transistor. Our aim is discuss about the BJT, bipolar junction transistor, which is commonly or briefly named as the transistor. The bipolar junction transistor, basic concept over this like definition or construction or structure and symbols. The BJT is the bipolar junction transistor and it is basically a three terminal semiconductor device in which a dissimilar type of semiconductor is sandwiched between two similar. Between the two similar type of semiconductor, a dissimilar semiconductor is introduced. So, and basically it is used for amplification, switching device, converter, and automatic switch, and in temperature sensor. So overall it is a three terminal semiconductor device. Now see, we can easily understand the definition from this. The three terminals are named as emitter, base, and collector. The three layers, if we consider to introduce p-type between two n-type, then that is known as NPN transistor. Another structure also possible between two p-type, we can introduce a n-type. So whether it is this type of structure or this type of structure, the basic meaning is at the middle we are introducing a dissimilar between the two similar. And accordingly we have two types of BJT. One is known as PNP transistor, another is known as NPN transistor. And to differentiate between these two transistors, there is a arrow mark difference only. Inward arrow means that is PNP transistor, outward arrow means that is NPN transistor. So till now we are confirmed about the structure and the symbol and the name of different terminals. Then the exact classification of a transistor. Actually, the name transistor is divided into two categories. One is BJT, another is FET. Bipolar junction transistor is BJT. Again, BJT is divided into two categories. One is NPN and another is PNP. So, our chapter is mainly based on the BJT. Then another chapter is based on the FET, field effect transistor. So, let us ignore about the field effect transistor in this portion. We focus on the BJT fundamental. Then, before going inside the transistor in detail, we have to know about the three layers, basic idea about the three layers of transistor. One layer is known as emitter, second is base, and third is collector. So, what about the emitter? This should satisfy by the emitter. Basic requirement of a emitter is it should be heavily doped and its width is basically greater than the base but less than the collector, and it is always forward biased, and this is the main portion which provides the majority charge carrier which is helpful for entire conduction of the device. So this will emit the majority charge carrier. Accordingly, its name is emitter. Then what about the base? Basic idea about the base. While we are constructing the base should be very thin and lightly doped, and basically it controls the amount of charge coming from the emitter. Emitter is the main that will emit the majority of the charge, producing the current within the transistor. At the middle, the base will control the charge coming from the base, emitter region. Then next we collect the basic concepts about the collector. The collector is basically reverse biased and its width is more than the base and emitter. It is always wider than other two. Then it is moderately doped. It is not heavily doped as in emitter and not lightly doped as in base. Then it removes the charges from collector to base junction. So this point we can be very clear while we are considering the working principle. What is the meaning of removes the charges from collector to base? Then actually here we have covered three words: lightly doped, heavily doped and moderately doped. So what is the meaning of these three? Doping means the process of adding the impurity. Already we covered in PN junction chapter. The amount of impurity added to form a semiconductor vary. Actually, it vary from device to device. Similarly, in this case, we have three layers: emitter, base, and collector. So, while we are constructing the emitter, that is heavily doped, means we are adding more number of charge carriers as compared more number of impurity as compared to base and collector. Similarly, base is told us the lightly doped. Lightly doped means while we are designing or constructing the base region, that portion is lightly doped, less number of impurities are added. Then collector is moderately doped means medium, not that means in this region the impurity amount is not so high as in emitter or not so less as in base. So accordingly we have three words and we can be very clear. So based on the amount of impurity we are putting the word like this. Then next we consider about the working principle of NPN transistor. Actually this is a NPN transistor structure, and for proper conduction of an NPN transistor, two DC sources are required. One is connected across the emitter to base in forward direction, that is named as VEB in this case, and another DC source is connected across collector to base in reverse direction. These two DC sources are must. Whatever may be the way of providing the design process to provide these two DC sources, the requirement is always two DC sources must. One should be across the base to emitter, another is across collector to base. This is emitter and this is base and this is collector side. Now you can verify this is the DC source VEB is providing the reverse biasing because VEB is providing the forward biasing. N type is connected to negative and P type is connected to positive. The DC source VEB is providing the forward bias. If we interchange this direction of power supply, DC power supply, our transistor should not conduct. And now we can verify whether conducting in this way or not. So this should provide the forward and this should provide the reverse. Now 2 points complete. Two DC sources must, one should provide the forward bias, another should provide the reverse bias. Now whether the transistor is conducting or not, simply we can prove theoretically. We know in N type the majority carriers are free electrons. Since emitter is heavily doped, we get large number of free electrons in this region. But base is lightly doped and very thin, so we get less number of holes in this case. Here we consider only the majority carriers. This is reverse bias, so no majority carrier role in collector. Now, how we represent theoretically in a diagram? Large number of free electron here, less number of holes here due to lightly doped. That is why as per this diagram, here you have a total 5 free electrons, but here only 1 holes. So this indicates you have large number of free electron here, but less number of holes here due to thin and lightly doped. But practically the meaning is if you have 100 number of free electron here, then 5 number of holes will be in base region. Accordingly, the material is designed. So now see, due to this power supply, all the free electrons will be attracted towards the base region or repelled by this negative terminal of the DC source. This is negative and these are negative. So all the free electrons will be repelled towards the base region by this negative terminal. When all the free electrons will be moved towards the base region, there are very little number of holes in base region. Suppose one hole here, so one hole will combine with one free electron and neutralize. The remaining 4 free electron will go towards the collector region. Because your collector is a strong positive, now your collector terminal is getting strong positive supply from VCB. So this positive will attract all the free electrons towards the last end of the collector. And practically if we study, this voltage is greater than this voltage. So accordingly, while all the free electrons will go through the base, at the end of the base region, this strong positive will attract all the free electrons towards the last end. So as a result, these free electrons will move and pass like this. Again, the number of electrons combined here that will return in this way, and both free electrons will combine and go and return to the original position. The final conclusion is, within the transistor we are getting a continuous flow of free electrons, means your transistor is conducting. Because theoretically how we prove a medium is conducting? If we are clarifying the any region, there is a flow of continuous charge of flow of charge carrier that is conducting. So your transistor is conducting and majority current is due to free electrons, and the direction of current is just opposite to the electrons. Similarly, just opposite for PNP transistor, same process, only in place of free electron we are taking holes and battery supply is just interchanged. Thank you. Next class we discuss slight more about the connections of transistors.